How about look at number 2? So this is a very similar problem than before. We saw a similar problem before, right? So what is the answer for 2? Again, the reactions take place in an isolated container. So the temperature goes down, right? What does it mean? The kinetic energy goes down, the total, right? So the potential is going to go, right? So what's the correct answer? D, right? How about number 3? How about number 3? Okay, for number 3, we need to remember, you guys, if you talk a lot, then we cannot really do anything. How about if we cool down a little bit? For the number 3, we talk about the formation reaction, and we should remember the definition, right? Formation reaction of a compound is a chemical. It's expressed with a chemical equation that has the reactions in their most thermodynamically formed as elements, right? And the same thing, the compound is in most thermodynamically stable form, and it's 1 mole. When you balance it, you have to have 1 mole of product, okay? So, first one goes immediately out because it's 2, it should be 1, okay? And then, when you have carbon, you already know, because you have heard it. You didn't measure it, did you? You just believed it, right? Carbon, diamond, graphite, 12 topic forms between them, that which is more stable, less energy. Gibbs energy, we'll see later on what Gibbs energy is the, which one? The graphite, right? Is the more stable, the lower energy. So you have to have graphite. So immediately the E is rejected, right? So we have between B, C, and D. All right? Now what is the ethanol? Okay, ethanol, what is ethanol? Is it liquid, solid, gas? What is it? It's liquid. You should know that. Right? What? It says it? Oh, okay. Well, yeah, because otherwise you don't. Maybe some people don't know. Okay? So it says liquid, right? So you see solid and liquid gas, so you have to choose that one. Right? Standard state conditions, ethanol is liquid, so then you choose what? So the answer is C. This number 4 could be a little bit challenging. Makes you really dizzy to look at it. You know how to do the problem? How many people know how to do this problem really fast? Raise your hand. You know we will tell you. It drives you crazy if you don't know how to do it. It really does. It makes you really dizzy. How many people want me to do it? Let me see your hands. There is a way to do it, otherwise you really get confused how to answer this problem. Okay? So what you do is, you have a problem like that, what you do is this. You put these temperatures in a column, right? So let's say we have, which is the smallest. First of all, this one has to be converted into Kelvin, because we want to compare they have to be always the same units, right? So the first thing you will have to do is to convert the 177 into Kelvin, which will be what? Temperature in Kelvin is equal to temperature in degrees Celsius plus 273. That means temperature in Kelvin at what? Of 177. It will be how much? How much is that? $450, right? Did I do right? Okay, 450. So let's start from the smaller one. So, so let's start with, you guys are playing games, huh? 290 Kelvin, and then we have what? 298. Then we'll have what? This goes up. What do we have after? 310. Then what? 400. Then what? 450. And then 500. Okay, can you see that? What is the one that, okay, so 500 is what? B. 400 is what? E. 310 is B. 298 is C. And 290 is A. Okay? So this problem, you really don't do it unless you look here. If you look there, then you can do it. By knowing what? If you are above the critical temperature, in other words, what do you mean if you are above? Not yourself. You better look better. If you have a gas, right, that is a temperature above its characteristic constant, which is called critical temperature. So if the gas is above its critical temperature, right? Let's say the gas critical temperature is 10 degrees Celsius, and now it is in 100 degrees Celsius. That means above its critical temperature. So when a gas is above its critical temperature, you cannot compress it and make it liquid. See, liquid forming, right? So you know that, according to that, and to know that the gas that we're talking about is what coming at what temperature? No, excuse me. We are at 400 degrees Celsius, right? We are at 400 degrees Celsius. In fact, you can say all these gases are here, and therefore thermal equilibrium, they're all at 450 degrees Celsius, right? Kelvin, sorry. Right? They're 450 Kelvin. So it's asking you which one is non-permanent. Non-permanent. That means if we compress it, it will liquefy. That means it is not above its critical temperature, it is below its critical temperature. Right? So the temperature is below its critical temperature. Which gas is that the temperature it is below its critical temperature? D. Can you see that? How many people got it? Raise your hand. Okay. How many people did not get it? Raise your hand. Well, maybe your mind is tired right now. You didn't take a nap. You should have taken a nap.